Literally, the words at the top don't matter to you because it's always going to be the same function all the time. Do we kind of remember this, maybe even this particular function for rates of change? If not, it's okay, but it's always the same. Show that P satisfies this equation. That means you've got to differentiate this and hope to get to this. Let's see. I'll leave it with you guys for a minute or two. Okay, let's do it. What is a derivative of AEKT? What's the derivative? K-A-E-K-T. That's not what he wanted. You wanted it to be K times P. Do you actually have K times P? No. Yes, you do. Don't say no. K, there's the P. There's the P. See what I mean? Second year round, like last year, you guys were like, what? I don't get it. I mean, now you're just like, yeah, of course. Right? Just like straight away. Yeah, of course. Done. It's finished. KP. Double I. If the population at the start of 2006, when t equals to 1, was 147,000, and at the start of 2007, when t equals to 2, was 154,000, find the values of A and K. I think we all know what we're going to do now. Yes. We're going to simultaneously solve it, correct. When t equals to 1, p equals to 1, so 47. So 147 to 100 equals AE to the K. One. The second one is 154,800 equals AE2K. Oh, I like it because let's see who feels super comfortable solving these two simultaneously. What are you going to say for me to do? Don't overkill it. It's not going to be anything too magical, too crazy. Just tell me what you can do. Maybe think of, he said simultaneous, maybe think of that particular topic. Think of what you've learned. Sorry? 100%. You don't even need to overkill it. Make A the subject. In one, sub it into the other one. So let's do that. So from 1. A equals 147 to 100 over e to the k. We'll call that number 3. Sub 3 into 2. It'll look like this. 154, 800 equals A on EK times E2K. Yes, no, maybe. What can you do when the bases are the same? What do you do to your indices if the bases are the same? you subtract the indices. So E2K and EK, what happens? E2K and EK, what happens? Well, according to your index laws, when your bases are the same, you subtract your powers. So what's 2K minus K? Just K. A lot of students have a tendency of cancelling out this, and they're left with like 2 or something. It's not like that. Don't do that. It's actually more like this. Yeah, EK, and then the squared cancels out. So you're still left with e to the k, technically. Or you do what I said, 2k take away k is just k. Okay, what do you do with this number here? 147, 200. 147, 200. What am I going to do? Remember, you're solving for k. What are you going to do with this number? Not minus, not add, divide. Divide because multiplied. Wait, take your time, take your time. I'm at 154, 800 equals 147, 200 times E2k, or EK, sorry. I would divide it over.
Look, those two are times together.
Yeah, what part are you saying?
I don't know, for some reason I would
have.
I would have minus it.
You could only minus it if there was a multiplier. So if it was 154, 800 equals 147, 200 plus E2k,
yeah,
then you would minus the 147. The fact that it's multiplied, I guess the way you would have to think about it is, how is it attached to the e to the k for me to get rid of it? Well, it's multiplied, so I've got to divide it. And then you'll divide it by 147. That's it, really. So yeah, 154, 800 over 147, 200 equals e to the k. And whatever that gives you in your calculator. 154,800 over 14147,200. 387 over 368. Now what do you do to both sides? Log. So k equals log of 387 over 368, which equals 0.0503. 0503.
What was the point of simplifying that fraction?
What was the point of simplifying? No point. Seriously, no point. Yeah, you're going to write it as a decimal anyways.
Don't you do that as a log and a fraction? Because like k equals 11.
No, not for this topic. For this topic, unless it says exact, fine. But you actually want to use more the decimal in your writing. But you keep exact in your calculator. So me right now, shift, store, A. My K is locked in as A. Okay, we're not done. Obviously, you still got to find A. So then you go back. A equals 147, 200 over e to the k. But the k I'm subbing in is not that k, it's the actual k. So 147,200 over e to the alpha a. 139973.13. It's big A. Feels weird. Oh yeah, because 147 is really large. Okay, all good? Yes? Find the population at the start of 2009. How many, what does T equal to in 2009? If T equals to 2 in 2007, T would equal to 3 in 2008, T would equal to 4 in 2009. So just take your time. So for triple I, what's the equation? P equals AEKT. P P equals A, E, K, T. A we have 139,973. K equals 0.0503. T equals to 4. And then you'll get your population at the start of 2009. So 139,973.13 e to the alpha A times 4. 171,197. That's it. 2009. And then last one. Find during which year the population will first exceed 200,000. What letter are you looking for? T. Yeah, T. You gotta know that. So you're looking for T when P equals 200,000. So again, what's the math? The math looks like this. 200K equals A, E, K, T. We already have A and we already have K. So how do I get rid of A? Divide it over. So 200,000 divided by 139,973.13 gives me 1.43 equals EKT. Shift store B. Yep. Then what do you do to this answer? Log it. Then you divide by T is equal to 7. So it says in which year though? So when T equals to 7, which year is that? 2009 was T equals to 4, T equals to 5, 2010, T equals 6, 2011, T equals 7. In the 7th year, i.e. 2012. Are we all okay with me getting to T equals to 7 like that in our calculators? So again, 200,000 divided by 139, blah, blah, blah. Then you got to 1.43, logged it, divide by K. We can do that? We can? Matter? Yes? You sure? I don't know. I've known you for a while. I know your head nods. Frustrating. Someone knows you. Question 8. All right. What's another one? What's another one? What's another one? No, it's all out. It's all gone. It's not a bad one to do. Okay.